This is the second of 4 videos to accompany the Further Mathematics conference session, Getting a Feel for Further Mechanics. In this video, we'll look at exploring the ideas covered in the previous section through practical work. Here is a simple practical setup for exploring the relationship between energy and projectiles. Here we have 2 balls, one placed on the tabletop and one fixed by a short inelastic string to a fixed point. The red ball is raised up to a given height h and released, hitting the yellow ball and projecting it with an initial horizontal velocity off the edge of the table. The question to ask students to explore is there a relationship between the height at which the red ball is released and the distance horizontally that the yellow ball will ultimately travel? Most students will probably say yes. The higher you release the red ball, the further the yellow ball will travel. That seems to be good common sense. And so we can press them further by asking them a subtly different question, which is, what is that relationship? We could ask them to make a specific conjecture. For example, if we double the height of the red ball, will that result in the horizontal distance of the yellow ball also being doubled? Or will it be some other scale factor? Asking students to speculate and then explore will help to improve their instincts when it comes to mechanics. Knowing when to trust your instincts and when to question your instincts is a really important skill in mathematics generally, but perhaps more so in mechanics than any other area. Once students have had a chance to work through their calculations and their thoughts, it's a nice idea to give them the opportunity to explore this practically. Here the experiment has been set up using a banana hook that might be found in the kitchen. Students will get a buzz if they predict correctly what will happen as they vary the height, and if they find that their prediction was wrong, this is a good stimulus for asking further questions. Once we're ready to analyse mathematically what is happening, a good place to start is to do some simple energy calculations. Let us start with the red ball. If we assume that the tabletop is the point at which we say an object has 0 gravitational potential energy, then releasing the red ball from rest means that all its gravitational potential energy is converted into kinetic energy by the time it reaches the yellow ball. If we now consider the yellow ball, it's given some initial kinetic energy when the red ball hits into it, but then it follows the same situation as the red ball in the remainder of its journey. In other words, it loses gravitational potential energy and gains kinetic energy. If we try to be a bit more precise with this, starting again with the red ball, its initial gravitational potential energy will be mg multiplied by the initial height h. By the time it's reached the yellow ball, that's all been converted into kinetic potential energy, giving us this equation here. We can rearrange this to make the velocity that it ends with the subject as follows. So we have an expression for the velocity of the red ball when it comes into contact with the yellow ball. We will now consider the yellow ball and apply a projectile model. We can see that initially it has horizontal velocity given to it by the red ball, but no vertical velocity. The time of flight is dependent only on the vertical motion. So if we start by considering vertical components only and applying the constant acceleration formulae, we can get an expression linking the height of the table and the time for which the ball is in motion. If we consider what happens horizontally, we can again apply horizontal components and apply the constant acceleration formulae, and we get an expression connecting the time and the horizontal distance. Substituting the first into the second shows that the horizontal distance d is proportional to the initial velocity uy. This is assuming that h, the height of the table, is kept constant. Looking back at the first expression in the red box, we can see that the final velocity of the red ball is proportional to the square root of the height h, giving us these two conditions. However, there is one thing that we haven't fully explored, which is what happens in the interaction between the red and the yellow ball. For example, is all the energy that the red ball has transferred to the yellow ball? And if not, does that affect the assumptions that we have made? We will explore that further in the next video.